we have a MacBook Air. So this one is a liquid damage. So whenever you see a different color from space gray, especially this form factor is a form factor from 2018 and above. The older ones from 2017 were discontinued, which is the A1466. These were discontinued in 2017. From 2018, a new form factor Apple decided to change, which has also been changed in the M2s, and also with the 15 inches lineup of the MacBook Air that's added. Okay, this actually powers on, because I see there is a feedback on the trackpad. So one of the easy way you can identify if there is power on your board or there is power on the machine, it's the feedback from the trackpad. So with this feedback, with the trackpad, this particular trackpad design, when the device is off, it's going to be, the trackpad will be as hard as the body here. But when you have power on the machine, then the trackpad will actually respond. You get a feedback on the trackpad. So I do get feedback on the trackpad. So that could be that the machine is in a particular state, or it could be that is the problem that he's having. There's feedback on the trackpad, and that's about it. Most likely, there are many scenarios that that you find a device having trackpad feedback, but nothing on this, coming from the machine. So we just need to identify what it is. Sometimes again, when your battery is down, when you have a low battery, that can also be a thing. Because it's a liquid damage device, we are not going to plug our charger to it. Rather, we are going to open up the machine. We'll take out the back cover to see exactly what is happening. So to do that, we need a P5 for the back. Now, particularly so let's just identify what model this is. We know it's from 2018 and above, but the model is going to be, what model is it? This is an M1, A2337, that's an M1. So, what we are going to do, so we are going to take out the screws. Now, particularly with the M1, and also the Intel, the screw configuration is slightly different. Now, the first one, the far right and the far left are going to be of the same size, and then the two in the middle will be of the same size. So now these are going to be long, and then these ones are going to be short. Now this and that are the same thing, and that and this and that are also the same sizes. So you have this pair, that, and then followed by this pair. See the way it looks? Now, the one in the middle, it's going to look different from that. You see the difference? So, see the difference? So this two, while this are going to be in the middle. Okay. Then the rest are going to be of the same size. Zion, turn down that volume. Turn down the volume. Turn down the volume. So the rest will be of the same size. Now the two here will be here, that will be there. Okay, so you see this section here you seem to see traces of liquid in this section here, and on the board seem to be fairly okay. The first thing we want to do is to disconnect the battery. So we want to first of all release the battery clip. The best way would be to use your fingers, and if you don't have, if you're unable to do so, you want to use a sponger. Avoid using a metal object, tweezer. It's not ideal to use that. So that has been disconnected. This side of the board seems to be fine, but then we need to see what the other side of the board looks like. The side of the board, which is the audio board, seems to be corroded because of what we see here. Nonetheless, we are going to take the board out. So we are going to start by using our T5. So to take the board out, we start from here. First thing first, we have disconnected the battery. Now we want to start from here. So we want to take these two screws out, and be aware that the screws differences. Now these two here are going to be completely different from everything else on the board. I have a pair here, that's two, and then the ones on the board 1, 2, 3 are going to be exactly the same, and then this obviously stands out because of the type of cap it has. So 1, 2, 3 are pairs on their own, 1, 2 are pairs on their own, which are not the same. So these two cannot be used. You don't use none of this anywhere else, only this and that. Now these three can be interchanged in terms of you can bring this one here or bring that here, it doesn't matter. So 1, 2, 3 are the same thing. And then this stands on its own, and then the one for the USB-C charging port also stand on their own. So let's quickly take that out. Stands on their own, and then these two stand on their own. Now, especially when you're working on a MacBook Airs of this design, you want to leave the DC jack on the board, but then you want to take out the screws that holds the DC jack to the frame. So if you look at those two, they are not the same. Those two screws are not the same as those. They might look similar, but they are not the same. If you look at them, you will see that they are not the same. Now we take that out, and we are still using our T5. Next thing is, after that, we now want to move on to our T4. So I'm using the T3 because my T4 is slightly bigger than what I require. So I'm going to use a T3. So now I want to remove the screen the screen cowling, the screen shield. I'm going to remove that. So that's the only one that I need because of the cable that runs on the board to the screen assembly. I don't have to remove that, and I don't have to remove that. Now those are the only two that I need to remove, and this guy here also I need to take that out because of the IO board cable. Okay, so that, and then my trackpad cable. And then what else do I need? Okay, Wi-Fi connector cable, and that's it. So now I can disconnect my cables. All of the screws are out. I can disconnect my cables. I'm not going to worry about disconnecting the touch ID cable, which is also the power button. I'm not going to worry because I'm not going to be needing, or I'm not going to worry about that section of the board. So I only need the board from this side. So because there is an opening, and by the way, this cable, it's not coming from this side. So there's I'm talking about this cable here. The touch ID is not coming from this side, it's coming from that side. So the only thing that comes from this side is this cable here, the IO board cable. So once that is out, now you have an opening from that side. So now I can disconnect the cables, and then I take my board out. Now you always want to look for an opening. So since there is an opening here, that means you can take the board out from this side, correct? Okay, the board is out. So what we want to do now is because the device is liquid damage, we want to take out the audio board, and there are other function of this audio board here. On it, you also have a speaker connected to it. On it, you have your Touch ID, as well as your power button, which is a multifunction. Your Touch ID, your power button, connected to it. Now all of that function is now fed to the board through this cable here. So we want to take that out because the device is liquid damage. Ideally, we wouldn't worry about the audio board cable, the audio jack cable, but because the audio jack board, but because the device is liquid damage, we want to make sure that we have a better view of what that looks like. So let's disconnect that. Zion, turn down the volume. Zion, turn down the volume.
Not working at the moment. So,
Okay. So our audio jack board seems to be okay. We don't really have we don't see anything that seems to be a concern here. So we are going to put that back. It's important whenever you're busy with these devices, especially if it's your first time, to really take care of the screws and where they're coming from. Okay, so let's put the shell on the side, and now have a look at our board.
Accessibility shortcut 22 items, voice mode off.
Okay, so you see this side seems to be fine. Now let's see on the other side. Okay, it seems like the only problem that this seems to have is the I/O board cable, which is this guy here. See a bit of a that seems to be the only thing that I see here. Okay, so with that out of the board, let's see what do we have on the board now. So now I see that it looked to be safe to connect power to it. So now we want to connect power to the board to see what we get. Oh, by the way, let's open up the board view. This is going to be an E20-2016. Yeah, E20-2016. That's the M1 board. Board number 2016. Yeah, that's it. That's the M1 board. Okay, so let's say this is going to be our PPDC in our USB-C charger controller IC. I'm talking about the 20 volt primary, the USB-C output controller, primary port controller. So which is UF400 and UF500. So let's see what we have on our PPDC line. We are going to utilize this fuse here. So we are expecting to have 20 volt on this line. Okay, switch our multimeter to voltage mode. 20 volt to suggest that that section is working. So we are going to use this fuse here, which is this guy here. So our black probe to ground, and then our red probe to the fuse. And that is 20 volts. That is good. Let's see what we have on our PP bus. We can get PP bus voltage on this guy here. Now PP bus here, and remember, I mean, in our previous video we did mention that when you get 12.0, that's indicative that you have 20 volt on your PPDC, and also that the board is making its way into SO state if it's not already in SO state. So let's see what we have on our PP bus. We can use either of this capacitor. So let's see what we have on PP bus. Can you see that? You sure you're not too far? Okay. Okay, so let's see that. Yeah, 12.0. Now 12.0 is that's good. Now let's now check to see that our machine is working. So it might just be that what's affected is the IU board and IU board cable. That's the audio board and audio cable. So let us let's put the board in the shell to see if that will solve, if our problem will be solved without that cable. We're gonna have so just enough screw for the testing only. Okay, so we're only going to connect the relevant cables. So right now we're leaving that cable out. Let's see what we get. We're also not going to connect the battery because we don't really need it. We have feedback on our trackpad. Okay, I see. We actually have image, but we don't have backlight. I don't know if you see that. So the device actually powers on, but we don't have a backlight. Okay, let's see that. Okay, so what we are going to do is we are going to get another board to quickly confirm that we don't have a problem with the screen. Let's quickly get another board to confirm that we don't have a problem with the screen. Now before we do that, let us also see what do we have on our backlight output. Let's just confirm that we have image. That's image. Can you see that? We have image, we don't have backlight. Now our backlight output is going to be, we can measure for backlight output on this capacitors here. So where it says PPV at LCD backlight. So we want to see what is it that we have on the backlight output. So the backlight output is going to be this guys here. So one side is going to be the main line, and then the other side is going to be ground. So let us see what we have on our backlight output. We have our black probe to ground, and then our red probe. Okay, that is 0. Can you see that? Okay, so it shows that it is 0. So now what we want to do is we want to see if we have a short on our backlight output. Because there are a couple of scenarios that you're expecting when it comes to what you get on the backlight output. You can either get PP bus voltage, which will tell you that it is not boosting. You get 0 volt sometimes when the fuse itself is not even when the circuitry is not opening. And then you will get also sometimes 0 volt when you do have a short on the line. So let's see if we have a short on the line. Okay, this is a very tricky one. You see how it says. You see how it says. Remember the other time I was saying that when you are now. Okay, so there are certain measurements that you want to do. Depending on the line, that will determine what you want to, the form of measurements to use. You know, I use this guy here because it's very loud, correct? Now, if I do this, when I measure black probe on ground and then my red probe on my output, I get 0.39. Now, yes, I did not hear it beep, correct? However, that is a short because it's not supposed to be that low. Do you understand? Which is why, even though I didn't hear a short, I need to see the figures that I get. Do you understand? So the same thing applies. That can also be reversed. Sometimes you may get a short, you may get a beep, but you don't have a short. You need to look at the figures that you're getting. Do you understand? So sometimes you may get a beep, but because it's a low it's a low resistance line, what will happen is it beeps and then you think you have a short, but no, because that line is it has a low resistance to ground. You might think that your problem is that actually you have a short, but no, you need to look at the numbers that you're having, and the same thing applies. Now, yes, we didn't hear it beep, but then the numbers are low. So I'm going to get another board to show us what we are supposed to get on that line. Now, that is not the type of line to get 0 point something volt on. And then another thing is, usually on a line like this, I would want to use my diode board measurement and not my continuity measurement. But nonetheless, I'm going to get another board to show us what I'm talking about. Okay, so we have another board here. So on our backlight output, I want to show us what we are supposed to have. So my black probe is on ground, and then my red probe, I place on the capacitors here. Either I can use any of the capacitors because all of them are on the same line, which means they are all the same. Are you sure you can get this from that angle? Okay, so my black probe on ground, and then on my red probe in any of the cap. See where it says OL? So I'm just going to put that to ground. And then here, we say OL. But here, we are getting 0 for something. So we have a short, but not enough for it to actually beep. Now, which would mean that the short is not completely connected to ground. Now, so the first thing we want to do is we want to disconnect the screen to see if the short is coming from the screen. So if the short is coming from the screen, when the screen is disconnected, we will no longer have a short there. And we hope that it's not coming from the screen because that's going to become an expensive repair. But if we disconnect the screen and the short is still there, then that's actually a good thing. We actually want the short to remain even with the screen disconnected. But if the screen is disconnected and the short is gone, it's not so good because it becomes an expensive repair. So especially because the device is liquid damaged, chances are that liquid got into the display assembly. So let's disconnect the screen. Screen cable is disconnected. Now let's check again. Black probe to ground, and then our red probe on our backlight output. It's not good. You see the problem? Problem is the screen. So now the short is gone, correct? Now our short is gone, but when we connect back the screen, let's check again. That's quite unfortunate. Okay, so now yeah, this becomes an expensive repair. Now there are two ways we go about this. So this is not so good. So on previous designs, it was easy for you to just open up the display and remove the screen cable and then replace it, or to access the board inside the display screen was easy. The A1502s, the A1398 for example, it was easy, but now the way these are designed, okay, another, yeah, it's not good. Yeah, it's not good. So there are two ways this can work. We can either take the screen out and then transfer the screen into a different housing. So we remove the LCD, transfer it to a different housing with the hope that that fixes it. Yeah, and in the process of having to also transfer, and then whatever it's affected on the screen board, we can also address that. But ultimately, it becomes an expensive repair. Yeah. So let's okay. I'm gonna get another. There were two. Remember those two machines that I said we put aside to test the screens? Where did you put them? Are they on your desk or inside? Inside the box. So can you come show me? You can pause the video.